Okay. So students, today we are going to see a very important question based on stiffness matrix method. So before we go to the question, I'm starting with the basic steps for the method. Okay. This the steps are like this. So initially, whatever beam or frame we get, we will first see what is the degree of freedom. Okay, so sometime it may happen that decay will be already given in the question. Okay, so degree of freedom or decay, kinematic indeterminacy we call it. Second step is we have to assign coordinate as per the decay. Suppose number of decay is 2, so then we will name the coordinate as 1 and 2. Third step is to calculate stiffness coefficients. Fourth step, then we have to determine based on stiffness coefficient and based on coordinates, our stiffness matrix size will be decided. So the stiffness matrix will look like this. This is just an example of 3 by 3 matrix. Now here, every coefficient, say K11, what does that mean? So K11 is effect of whatever unit force acting, okay, unit force acting at place 1, at coordinate 1, and its effect on the same place. Okay, so suppose if there are two coordinates 1 and 2 or 3, so if this is, say this is, unit rotation is like this here, and this is how, because of the unit rotation at this point, this is the shape we are getting. Okay, so say this is 1 and this is place 2. So because of this unit rotation here, there will be some moment created here. So let us call it as 4EI by L. Okay, and this is 2EI by L. So K11 will be effect of unit rotation or unit force at coordinate 1. Okay, uh, force acting at 1 and at the same place. What is the effect of 1 at 1? Okay, effect of this unit force at 1, okay, due to 1. So 1 के वजह से what is happening at the one place only. So that is what we are going to write at K11. Now K12, okay, when you apply unit rotation at 1, what is the effect at 2? That we will be seeing. So K11 will be 4EI by L, K12 will be 2EI by L. Okay, so this way we have to see. Now if it is like, similarly, if there is a member where third place we want to see, so in that case what is happening when you apply unit force at 1, then what is the effect at third coordinate? So that's what we are going to see. Now in K21 is whenever any unit force is acting at coordinate 2, then what is its effect at 1? So that we are going to write. For 2 it is when that unit force is acting at 2, what is its effect at the same place at 2? So that's we are going to see. So same applies for remaining coordinates. So for K31 also, when you apply unit force at 3, what is its effect at 1? When some force is applied acting at place 3, so because of that force, what is happening at the place 1, that we are going to see. And when some force is acting at 3, unit force acting at 3, so its effect at point number 2, and this is 3 3. So because some force is acting at 3, unit force is acting at 3, so what is the effect at place 3? Okay, so this is the meaning of stiffness coefficients. I mean, this is how we are going to get our values, like I have given the example here. So similarly we have to find out all the coefficients. Once we get these coefficients, we have to then come to the fixed strain moments. Okay, we have to calculate fixed strain moments. And once we get fixed strain moments, so we don't need explanation here, because in slope deflection method everybody knows how to calculate fixed strain moments, right? So fixed strain moments ka standard table we have, so we have to follow that table, and as per the loading we have to calculate fixed strain moments. So we have used this method, basically fixed strain moment calculation we have used for slope deflection and moment distribution method till now. So once we get these fixed strain moments, then we will come to the next step, that is we have to calculate what are the forces acting or the reaction, okay, at those respective coordinates. So we have taken example that for certain case what are the coordinates. So suppose if we take three coordinates, okay, that means three degree of freedom we have taken. So in that case we will be calculating forces at those three coordinates. So p1, p2, p3. So what is p1, p2, p3? So p1 is total fixed end moment at first coordinate, and p2 will be total fixed end moment at second coordinate, and p3 is total fixed end moment at third coordinate. Now it can be a single value like mf of ab for a member ab. It may be just single value, but there may be a case when, you know, at one certain joint, suppose abc, for a line abc, there may be, you know, it can happen that b is a middle joint, okay, middle point here. So this is, if this is the case, so this is our coordinate 1, for example, 1 2 3. So in that case what will be p2? P2 will be fixed end moment at ba and bc. Okay, so two values will come here. So both the things it may come here. So it depends what type of structure we are uh, analyzing. Now once we get the forces, then we have to go to our calculation of uh, any rotation and deflection is there, whatever unknowns are there, that we are going to find out. But before that we have to change the sign of p values. Whatever signs we will get, whatever answer we will get, we will change its sign, and then we will use it in this particular matrix. Okay, so with the help of this matrix, we will get values of theta. Okay, once we get theta value, then we will use slope deflection equation and we will calculate the final moments. Once we get final moments, then we can calculate reactions and we can draw shear force and bending moment diagram. Okay, so these are the basic steps for stiffness method. Now we are going to see an important example where swaying of the frame is involved. Okay, so we are going to see it in our next lecture.